Alright, Worthington, I'm back again, and we're going to look at quadratic equations, which are very prevalent at the end of Algebra 1 and Algebra 2. Quadratic equations are any equations that result in power on a variable. Okay, so you can see them in different forms. Standard form, your old quadratic is laid out. You're going to have a head term that's going to have squared. Behind that, you may have other terms. And that's that. Vertex form is a form that actually allows you to find the very bottom or the very top of the parabola, that beginning point of that U-shaped graph, which is a huge point because it gives you the maximum of a function or the minimum of a function, depending on if it opens up or down. And then x-intercept or factored form allows you to find the x-intercepts of the parabola where the graph would hit the x-axis. So I got three separate equations here, quadratics, each in one of the forms, and we're going to work through that. So, if it's in standard form and you're asked to graph it, I tell you what, the easiest is a graphing calculator. Flat out, hands down. Put it in the graphing calculator and all the information is right there on the graph for you. If you don't have that, you're going to have to find the vertex point. And the vertex is going to be the x-coordinate of the vertex point, that guy right there, is gotten by taking negative b divided by 2a. So you're looking at this baby here and this baby here and working with them. So if I took this quadratic, negative b would be the opposite, of negative 6, would be 6 divided by 2 times a is 1, 2 times would be 2, so I would get 3 as the x-coordinate of my vertex. From there, you got to put that in there and figure out what y would be, the output. So, a little bit of work. 3 squared is 9, negative 18, it'd be negative 9, it'd be negative 1. Now when you find that point, in this particular problem, since this is positive, it opens up. You're going to have the minimum of the whole function. The smallest output in this function is negative 1. You'd probably pick a couple of coordinates on one side of that and plug them in to get 2 more points, because you're going to have to get at least 3 points on one side to get the curve of the parabola. So you put 4 in there, and you're going to get 0. You put 5 in there, and you're going to get 3. And then realize parabolas have symmetry, so you can go to the other side of the vertex point and put 1 at 2, 0, and 1, 3, and you will get an outline of that graph. Okay? So, that's probably the nastiest form to work off of if you want to graph it. Now, the vertex form model is actually a package of information that can allow you to find the beginning, the vertex point of the graph, instantly. Since the vertex is the starting point of a graph, it's the point that zeroes out the independent variable. So over here, we were searching really hard to figure out 3 would be the x-coordinate at the vertex. Not here. If I said, what would zero this out right here? X would have to be 3. Now if you put 3 in here, this all goes away and y is negative 1. So lo and behold, we get the same point as we had here. Now if you put 4 or 5 in here, you're going to end up getting the exact same thing, because I got the exact same equation. Just a different form of the same equation. Those are called equivalent. Okay? Now this third one is actually in what's called factored or x-intercept form. This one, a little bit different deal. You're not going to find the vertex point instantly, but what you can find pretty much instantly is if I put 2 in right here, that would turn this factor into 0, and 0 times anything is 0, so the output would be 0. So you can remember, when one of your variables is 0, it's an intercept for the other variable. So if x is 2, y is 0. Now, likewise, here I got another factor. If x was 4, y would be 0. Now this is why it's called x-intercept form, is because it can tell you right away where the parabola is hitting the x-axis. Now what's great about that, the vertex has to lie right on the axis of symmetry of a parabola. So to me, your x-intercepts are like your eyes, the vertex would be like your nose. So I know now that 3 is right in between those two, and that's going to be the x-coordinate of my vertex. Put 3 in here, you get -1. Every one of these problems produces the same graph because they're the same equation. So you got standard form, vertex form, x-intercept form. There you go. Got to be able to find that vertex point though at some point in time. Okay. Now, when you take your graphing calculator and you enter a quadratic equation in there, this happens to be a model for the height of an object launched vertically. And what happens, it gets launched from a height. This 2 here would be, it started at 2 foot. And it goes up pretty fast right away. The heights increase pretty fast right away. And then what happens, it stops. Gravity's taking over, it stops, it's going up, so it reaches a maximum height at some point in time. This is not the path of the object, this is just a set of heights based on time. And then it starts to come back down and the height is less until you go back on the ground. So this is a graphing calculator problem. So what is its maximum height? Well, you'd want to go into the calculator and you'd want to find the vertex point. Now you say, Mr. Kohler, I don't know how to do that. Remember what I just said, if it's in standard form, how you can find the x-coordinate of the vertex? Okay, you could take -b over 2a, which in this case would be, this is a, and this is b. You could take -40 over 2, be -32, and get 1 1/4 seconds. So the maximum height is not 1 1/4, it's 1 1/4 seconds, and you're at the maximum height. All right, so you'd have to put 1 1/4 in here to get the maximum height. But you can do that. A lot simpler to go on the graphing calculator and go second trace, which is calculate, and there's going to be an option that's going to say max, and you can find that. You have to go on both sides of the vertex point and get that. When will the ball return to the ground? Well, that's when this turns into 0. Again, use your graphing calculator. You go in second trace and you'll calculate and you can find a 0 as well. So I can't overemphasize to be able to use graphing calculators for your MCA test. When you're seeing quadratic equations and someone says, what's the graph going to look like, or what's it going to be when this is whatever it is, that's where those calculators shine.